In this screencast, we're going to show you how Docker and Unikernels can work together. The first thing we're going to do is to use Docker to build the appropriate development infrastructure for Unikernels. And we do this by a series of Docker files that build base Unikernel images for Nginx, PHP, and MySQL. Instead of being normal Linux containers, these are actually standalone operating systems that will boot as KVM virtual machines. We can look at this by inspecting the size of the individual container, and we can see here that Nginx is just 2 megabytes in size, so a very, very small binary that has no dependency on Linux and can just boot as an individual virtual machine. Now, we can launch the next Unikernel, and this is MySQL, and this is a standalone database that boots up, but instead of running as a Linux container, it is a completely independent virtual machine. So you can see here that it's been assigned its own IP address through Docker. And if we look at the logs, we can see that its boot process is very, very different from a Linux container. Instead of running inside a Linux namespace, this is launched as a KVM virtual machine. And you can see that the operating system has booted from scratch. And as it continues to boot, it initializes its basic infrastructure, such as its CPUs, and then goes on and initializes virtual devices, such as networking and storage. And instead of launching into a completely separate multi-user system, it actually exists only to run MySQL. So the only process running inside this operating system is MySQL. And all of the logs and so on are pumped straight to the console output. We can verify that it is a standalone operating system by running docker exec and just checking which processes are running inside the container that we just launched. If it were MySQL on Unix, we'd see a Unix process, but here we actually just see a kvm QEMU command line running as PID1. So this means that instead of mapping it to a Linux container, we've mapped it to a standalone operating system that has a completely isolated set of resources. But in order to make it seamlessly usable, we bridge Docker networking to the container, and all of the usual Docker hostnames just work. So we can use the MySQL command line to connect to it just as you would a normal database, except that it's running in a very, very isolated and resource-friendly environment. So let's complete our cluster now and launch a few more Unikernels in order to build a realistic web application. So we'd like to have PHP and Nginx serving some web traffic. And the PHP will run a simple blogging software called Nibbleblog. So what we've done here is launched 2 Unikernels, and they've been separately optimized and separately built in order to make sure that each of the individual microservices, Nginx and PHP, can have just the minimal set of OS functionality that they require. But if we look at the Docker PS, we can observe that the Nginx Fast CGI is using Docker port exposure to serve its traffic to the outside world on port 32778, and PHP and MySQL are running on the Docker internal bridge. All of the usual familiar Docker networking commands just work with Unikernels just as they would with Linux containers. We can quickly verify that Nginx is running correctly by contacting it via the command line using curl and noticing that the right static web pages get served. And then we can switch to a web browser to complete the installation of our web application. So on the website, we just navigate to the external host, in this case, monk.recall.org, on the port that was exposed by Docker. And at this point, we're in a standard PHP application, and the Unikernel is serving a normal web service as you would expect with Linux containers. The key advantage of using Unikernels in this deployment is the minimalism of the resulting operating system. There's no shell inside the OS, so as you use this PHP application, all of the state has to be persisted in the MySQL database or a local writable file system. There's no other ability to run commands, for example, by shelling out to binsh, and so any exploits that attempt to do this will simply fail with a shell not found error. This makes the system significantly more robust. And finally, we can also use Docker log in order to see the web logs from the Nginx Unikernel that we just accessed. For more information, go to unikernel.org.